Thank you so much for having me here today. It's wonderful to be here. At its core, my work is really about how we can use machines to understand the world around us, to look across the rich tapestry of global information, to really understand the diverse stories of our shared planet, to look across everything being said around the world each day. How can machines help us peer through all that, to look across languages, cultures, geographies, and to transform it into visualizations of what it means to be human itself, to literally map planet Earth in real time. Over the past quarter century, the Internet Archive's TV News Archive has preserved television news from more than 300 channels from 50 countries on 5 continents in more than 150 languages. But for more than 20 years, it sat as files on disk because we lacked the tools to be able to annotate and understand all of that material. You think about, no scholar can say, well, I want to understand how the shutdown is being covered on the news, and then look through millions and millions of hours of video. Like, we needed tools to support all of that. So we started with speech. With the Russian invasion of Ukraine, the Internet Archive began monitoring a number of Russian channels. But a lot of the journalists and scholars that wanted to understand that, they didn't speak Russian. And so first off, we began machine transcribing all of that. But the early machine transcription tools, so speech recognition, ASR, it supported only a single language at a time. And across much of the world, we're very multilingual societies. In the US, when we hear like a foreign leader speak, for example, they dub it into English. But in much of the world, you hear it in the original language, just with subtitles on it. So we needed something that could do that. So along came large speech models. And these tools uniquely, like Google's Chirp, uniquely support code switching. So as someone, as you can maybe see there in the right, that was actually an example broadcast, English, Arabic, Mandarin, all in 60 seconds, rapidly interspersed. And these tools can do it. And that's really fascinating to us because we can start to understand multilingualism. We can start to understand how stories are told throughout the world. And in the end, we use these tools to machine transcribe more than 3 million hours of the entire uncaptioned portion of the archive, totaling more than 14 billion spoken words. You just think about the sheer volume of that material. But of course, television also has a lot of text on it. And so if you think about a lot of channels, like you have everything from a little bit of text on the bottom to massive, a huge amount of text and just a little bit of video there. So we want to extract all of that. And so in the end, we OCR'd more than 19 billion seconds, totaling 6 quadrillion pixels, yielding 294 billion words, yielding 1.8 petabytes of JSON. And that's an interesting number because, we think about like OCR, like taking, book images and making them into text. We think small images. We say, well, the scanned images of that book are huge, but we're going to end up with a little bit amount of text. But when you do things at these scales, things change. Everything becomes massive and difficult to work with. So you can imagine, we have this television archive, we've speech recognition, we've done OCR. So already you can start keyword searching that. But what we really need to do is start understanding what's there. So we use Gemini, Gemini Flash actually, to watch all of that footage and to catalog it at about 2-second intervals to understand categorize it, to say, well, what type of coverage is this? Now, as a clarification, no data was used to train or tune any models. We used just the off-the-shelf models to do this. And in the end, we cataloged, thus far, more than 7 billion seconds of footage across 3.7 million broadcasts. But, amazingly, that cost just $48,000. That transformation, that is truly enabling that for the first time we can do things at this scale. But you can imagine, okay, so we kind of know the general category this fits in. But what we really want to be able to do is to catalog the stories that sit within that. So you imagine today, you go to like an online news website, and let's say you care about coverage of the government shutdown in the United States. You go to the homepage of any online news outlet, and you can see all the footage and say, okay, here are the stories about the shutdown, and go right to those. But for television, it's different. Television is 24 hours a day. It's just linear video. So Vanderbilt University in the United States, for almost 60 years, they've had human beings watch the evening news broadcasts, 30 minutes each across the big three, and then do that by hand, make a table of contents. And we want to do that across globally. We want to do it across all the languages and footage that are in this archive spanning back a quarter century. And so it turns out it actually works really, really well. You end up with things like this. So essentially, it watches the broadcast, and it says, here are the 10 stories that are covered in that broadcast. And things like location, keywords, entities, for indexing, because we want to be able to make a map. And so you can say, what stories are covering this area over here? But the really cool stuff is down there, framing and narrative. So we're starting to work with journalists and scholars that care about how stories are told. So it's interesting. If you look across the world, there's a lot of very similar metaphors and stories and imagery that are very common across societies, across time. But the way in which those stories are told, in some cases, has changed over time. And scholars, like when they study things like how do we tell certain types of stories, like during COVID, how did governments convey to people that they should wear masks or they should get the vaccine or what have you? That varied a lot across the world. And scholars, they've only been able to look at little bits and pieces of this. So for the first time, we can start looking at this at scale. Now, of course, what makes television unique is the visual dimension of it. So, we've been looking at like image embedding models, image description models, a lot of these tools to say, well, look at the imagery and help me understand what's there. Because ultimately, I want to be able to type a textual description and say, find all the drone coverage in Ukraine, for example, across these channels or these countries. And the tools are actually there. Like, there are some quite reasonable tools these days. But again, there are challenges because they're not always designed for the sheer diversity of the imagery of the world. But more importantly, if you've got a few million images, great. That's pretty easy to do today. If you're tens of millions of images, you start stretching things. But when you start getting to the tens of billions or tens of trillions of imagery, that's where things become much, much more challenging. So that's something that we're starting to do a lot of work on is how do we enable this, but also visual search. I want to be able to say, well, here's an image that I just saw on social media. Find me all the places that that's been covered. And we already have the tools where just using that alone, we can start doing things like, what's the density of military imagery on Russian television and actually track it. It's a really interesting indicator, tracking how the government feels it's doing at a given moment. And already we can do that using these very basic tools. But again, that's human-driven search. That's a human being saying, this is what I'm interested in, so go find that. Like, I'm interested in drone imagery, so bring that back. But what we're really interested in is using the tools that exist today. What we're really interested in is, can machines help us go beyond that? Instead of me as a human being saying, this is the story I'm interested in writing about, can a machine go through, look across that footage, and then actually tell me what's interesting there? And so we start to do that. So this is an image of one day of Iranian state television. And so what you see here is a foreign and domestic television. We extracted a frame every few seconds, and we did image embedding. And so at first glance, you say, well, that kind of looks like a mess. Like, what is this? But when you start driving into that, what you find out is they were covering the same story that day, but using very different imagery to convey it. So very different, same stories, but different imageries for a domestic versus an international audience. And again, scholars of media understand these things, but we've never been able to visualize or quantify that for the first time. Now, this is one country, one day. What about 3 countries, one day? Russia, China, Iran. So at first glance, again, it kind of looks like 3 different media systems. But it turns out they covered many of the same stories this day, but from very different visuals. And that becomes fascinating as you understand all the different ways that a story can be conveyed through visual metaphors. So again, that's 3 countries, one day. What about the entire planet for one day? So here, what we were looking at is we said, well, what if we take everything that we monitor? So for television, 150 languages. But for online content, print, radio, et cetera, we monitor over 400 languages. And so this is a single day of everything that we capture across the world visualized. And if you look into this, each little tendril is a sequence of stories. And again, so this is the planet on one day. What about the planet on 3 days? And when you start looking at this, you start seeing fascinating structures in this. Not our differences and our divides, but our shared stories and similarities. And you start seeing those structures that emerge about what makes us human itself. But again, we're all the way up here now. So what happens if we dive all the way down to one tiny little corner there? One day of COVID vaccine coverage. And what becomes fascinating about something like this is we can start seeing the falsehoods, the misinformation, start emerging in the little corners here, and then begin combining and merging together. You can start seeing stories. They're almost like galaxies. They basically come together, they inflect, they collide, and they come apart with different information. And that's a really fascinating piece to all this. But again, now what happens if we dive even further? Down to the individual entities, the people, the places, the things, the connections that connect all of this together. We can start really understanding what are the things that make up the stories around us. Now, from this tiny, we've flown all the way up, we've flown all the way down. Now let's go back up again. We can harness all of this, and we start asking questions like, could we map global happiness? Now, this is not how happy or sad people are. This is if you take everything said about a city on a given day, what do you see? How negative, how positive is the media about that city? And by the way, if you go on our blog, you can actually see an animated version of this day by day as a movie. But this suddenly becomes very powerful because we can start seeing, when you turn on the media, what am I hearing about this area? Am I hearing the good stories? Am I hearing mostly the negative stories about it? And then we can zoom even further up, and we can make a map of global tone, how positive or negative the global media has been over the past quarter century. Now, we've all heard that social media is what's tearing us apart, that we were this wonderful global society, everyone linking hands, and then social media came along and tore us apart, and all of our partisan divides, all of that social media's fault. But actually, if you look here, so this is how positive or negative worldwide media from across the entire planet has been since the late 70s. And what you see is it's kind of constant until the mid-90s, early to mid-90s. Well, that's when web news came about. And suddenly what happens is news outlets, they're not competing locally. They're not looking for a local audience. Suddenly they're competing globally. They're looking for a global audience. And this fundamentally changes things in terms of just when you start competing globally, suddenly, again, negative news sells. So we see a market shift that continues all the way through the end of this graph and then actually through present. So it wasn't social media that caused all this. It was the web itself. But when we start looking at things like this, at the scale of things like this, we can start seeing the emergent patterns of society. We can start seeing stories materialize. So this is actually the earliest glimmers of COVID, when it was still a SARS-like viral pneumonia of unknown origin. But OK, so we can see, OK, the story is emerging. Great, we can see suddenly there's this interesting story that's occurring there. What we're really interested in is how that's being portrayed. So we can look at not just at positive or negative, but for example, here we said, well, show me all the media across the world by country, how it's covering China on that given day. Is it portraying it as being strong, as being weak, and why? And the ability to do this today, the fact that we have tools that can actually go beyond just positive, negative, but what's driving that? And look at more complex things like strength or portrayals is incredibly, incredibly powerful. But this is where things get really interesting. So up until now, we've still focused on keyword search. Things where I say, OK, this is what I'm interested in, and I put it in terms of keywords. Even semantic search, embeddings, is still keyword-based. So we said, well, leveraging these tools today, what if we could do persona-based search? So I type up a one-paragraph description of who I am, what I am, and it actually goes out and then actually searches for all that material and finds the stuff that actually matches what I myself are interested in. So here, policy analyst for US manufacturer, tell me how the tariffs are going to impact my supply chain. And the ability to do something like that. And this is actually a fascinating one, because when it went through this, it said, well, in this particular case, we went a little bit further, and we said, you're a car manufacturer. And it picked up an article about a consumer products company that was having problems importing aluminum for their product. Again, no mention of automotive here, and we didn't mention aluminum up here. So traditional, even an embedding-based search engine would never have brought those together. But here it understood, well, this particular manufacturer, they use a lot of aluminum. It's the same type of aluminum described here. This is going to be relevant to that supply chain analyst. And you can do even further. You can say, well, I care about the president's trip to the Middle East. I want to understand AI. And that's an interesting one, because you can also say, I'm a deeply technical person, so find me the tech press. I want the nitty-gritty technical news coverage. Or I don't understand much about AI, so give me the high-level summary. And that ability to even tell what type of press that you want to see there. Or I just want to know where to put my money right now. And you end up with things like this. So again, a lot of Silicon Valley today, they're about, well, let's summarize the news for you so you don't have to read it. As a former journalist, that's a really bad thing. What we're interested in is like, how can you say, so think of it this way. No human being could read everything said on the planet yesterday about tariffs. Machines can. So the idea here is that the machine can read everything said across the planet yesterday, across all of the world's languages, and then say, here are the top 5 trends that I'm observing around the world. So what you're seeing here is kind of that top level, that one paragraph description of the major trends. And then beneath that, it goes out to an annotated, basically an annotated sort of bibliography. For each trend, here are the key articles that are supporting that. And this, to me, is really fascinating. Again, as we all know, large language models, they're auto-completion engines. They're not really thinking or reasoning like we are. But if you take that into consideration and you say, OK, so it's a glorified auto-completion engine, well, you can leverage that to do really, really interesting types of trend analysis. And again, one of the things that we're starting to look at is how can we bring other types of anomaly detection? So, again, models today, they can only read about this tiny amount of text, like 1 million tokens, maybe 10 million tokens under some things. How do you expand these to handle trillions of tokens? And a lot of that is leveraging sort of scaffolding that wraps around them. And I'll come back to that in a second. But still, this is a human being. I type up a description, I say this is what I care about, and then the machine goes off and finds material that's relevant to me. So it's still human-driven. Well, what if the machine could just go off and do the stuff on its own? I mean, you have to ask, why am I doing this search? So we said, what if you're a diplomat in the US State Department? Today, you'd use a tool like this to get a daily report of what's happening, and then you as a diplomat would sit down and think about how to respond to that. And we said, well, what would happen if you just had a machine? So we had it watch Iranian state television, and we said, every mention of the nuclear accord, we said, like, you're a US State Department diplomat. If it's for the accord, leave it. But if it's against the accord, write a point-by-point rebuttal right there. In English, in Persian, for social media, for mainstream media, for US press, for European press, and on and on and on. And it turns out it actually works quite well. And specifically for each country, it found very unique connections to that. Now, what's so fascinating about this, and what really spooked me about this, is we took this, and then we took stuff that the US State Department had actually had their human diplomats write, and we handed it to a bunch of people. And we said, was this AI generated? Amazingly, the stuff the humans did, the humans said, that's all obviously AI. Like, it's not even a question. That's so awful. The stuff the machine did, they were like, clearly this is human because no machine could have written that. And that was eye-opening to us because it reflects that so much of diplomacy is not people spending weeks and months in crafting these beautiful messages. It's a junior staffer sitting in a room with an hour to write a long press release that's going to impact something. And so the ability of machines to assist with that, to do these really, really fascinating things. And then finally, and you're hearing it here first, so we have all of this data. Every day we're monitoring the planet in over 400 languages. And so at the end of next month, we'll be unveiling a daily global trends report, a free PDF every day in your inbox, where what we're doing is bringing all these technologies together to look across the entire planet and to say, well, so it'll be 1 page per country, 1 page per major issue. And part of this is technology demonstration. So for us, this is a journey to say, well, how could you take petabytes of data each day and synthesize that using all of the available tools, not just large language models or large multimodal models, but more traditional neural anomaly detection, statistical anomaly detection, leveraging all these external memories, knowledge graphs. We've actually built trillion-edge knowledge graphs over the planet with this data, bring all of that together and weave it into a single view of global society. And this I'm really excited about, and I think it will really showcase what is possible today in leveraging machines to understand the world. Thank you so much.